Welcome to this lecture titled Teaching as a Design Science. In this lecture, we will explore a different way of thinking about teaching. Instead of seeing teaching only as an art or as a theoretical science, we will look at it as a form of design work, similar to fields like engineering or architecture, where the goal is to create learning experiences that help students develop knowledge, skills, and understanding. We will discuss how teaching involves designing activities, environments, and interactions, and how those designs can be improved over time through reflection, feedback, and collaboration with other teachers. We will also look at the role of digital technology and how it is changing both what students learn and how they learn. Finally, we will introduce the idea of design patterns as a way for teachers to describe, share, and improve their teaching practices together, building a shared knowledge base for the profession. The main goal of this lecture is to help you see teaching not just as something you do, but as something you can systematically design, evaluate, and improve. Teaching is often described as an art because it requires creativity and imagination. Teachers perform, adapt, and respond to students to engage and motivate them, building a productive connection between themselves, the learners, and the subject matter. In that sense, teaching has a clear artistic dimension. However, unlike many art forms, its purpose is defined. Learners should develop knowledge, skills, and capabilities. But is teaching also a science? Researchers study teaching scientifically, yet teachers rarely build or share formal theories based on experiments. Teaching is therefore not a theoretical science that explains the world. It is closer to fields like engineering, computer science, or architecture, which aim to improve the world through design. Herbert Simon described this difference in the sciences of the artificial, contrasting natural sciences with design disciplines. A design science uses theoretical knowledge but focuses on design principles and practical heuristics rather than abstract theories. It builds on existing knowledge and improves through practice. Teaching fits this view. It uses research on learning to design activities that support student development and refines those designs through experience. This book explores what it means to treat teaching as a design science and how teachers might collaborate, as other design professions do, to improve education. In this story, technology is a central but complex character, sometimes misunderstood, yet potentially helpful in making things work better. Education has always had a close relationship with technology, though most tools were not created for educational purposes. Writing was developed for commerce, books for religion, and slide software for business. Education later adopted these tools but rarely influenced their design. Only a few tools, such as the blackboard and the virtual learning environment, were created specifically for teaching. In general, education adopts technologies from other fields, which becomes critical in times of rapid change. Over the past 3 decades, digital technology has transformed work, leisure, and learning. Its impact has challenged the educational system, which has not fully absorbed it. The scale of digital change may require not just new tools, but changes to the system itself. Because digital technologies will shape education regardless, teachers and lecturers must take control of how they are used. They need to master these tools and direct them toward educational purposes. This requires education to take the lead in its use of technology. To do that, we must be clear about the purpose of education in the 21st century, while also understanding technological developments. For example, education did not ask for collaboratively written online encyclopedias, yet many students rely on them more than libraries. With confidence in technology, education can move from awareness to meaningful use. While it makes sense to examine each new technology for its educational value, education risks inappropriate uses if it is not clear about its own goals. The academic community must approach digital technologies from a position of strength, with a clear understanding of what education needs from them. These are knowledge technologies, because they shape both what can be known and how it is learned, directly affecting the educational process. Consider a business case studied in three ways. One student reads and writes about it, another participates in a role play, and a third experiments with a spreadsheet model. All may learn the facts, but they gain different kinds of knowledge. Reading supports analysis, role play builds experiential understanding, and modeling enables experimental learning. Each approach has value, but what students learn depends on how they learn it. Technology also raises concerns. Some argue that, because information is widely available online, students can educate themselves. This view assumes learning is just information transmission. Academic education is more than browsing information, and educators must define what learners actually need from it. Teachers remain essential. Technology makes their role more complex, not less important. They structure learning, guide thinking, and help students develop digital literacy. Education must be clearer about its views on knowledge, learning, and valid argument, while teaching students to use technology critically. Technology should offer more than access to information. The academic community must define its role and guide its use, or risk being led by it instead. Educators have long argued that the focus should be on learning rather than teaching, since teaching exists to support learning. But this raises a question. How do we learn about teaching itself? In education, feedback loops are weak. We set learning outcomes, design teaching to reach them, and then measure results through exams. These results judge students and institutions, but rarely the teaching design. In research, this would be like testing a hypothesis, and if it fails, blaming the subjects instead of questioning the hypothesis. This shows that teaching is not treated as a science. It also could not be, because teaching is more complex than fields like rocket science. It deals with independent minds, not just physical systems. Since students act independently, it is difficult to judge teaching only by outcomes, and important feedback is lost. Individual teachers do gain insights from experience, seeing what works and what does not. But this knowledge is rarely shared or made explicit. Unlike scientific fields, where ideas are tested and built upon, teaching knowledge mainly grows in the research community, not among practitioners. If teaching were treated as a design science, like engineering or architecture, teachers themselves would play a central role in building and improving a shared knowledge base. The idea of teaching as a design science has a history, especially in debates between positivist and constructivist perspectives. The key question has been whether good practice can be formalized into clear principles or depends mainly on individual practitioners. In complex settings, Shern suggested an epistemology of practice based on reflection rather than fixed rules. In the 1990s, educational researchers began treating education as a design science to move research from controlled labs into real classrooms. This led to design research, where theory-based teaching designs are tested, revised, and tested again. The goal is to improve both theory and practice through iterative cycles. Design experiments differ from laboratory studies because they deal with complex real-world situations, allow flexible revisions, and involve social interaction. Teachers and researchers work together in both design and analysis, creating a form of principled reflective practice. This approach produced guidelines for collaborative design, testing, and reporting of educational interventions. However, these guidelines mainly target research teams and assume specialist involvement, rather than empowering everyday teachers. Results are often shared as narrative reports, which may not be the most effective way for teachers to build shared knowledge. Design science research is also well developed in information sciences. While teachers may not match the rigor of research teams, the process resembles reflective teaching. Teachers draw on theory, classroom problems, and existing materials to design lessons, test them, and improve them over time. Ideally, teachers should practice design science as part of their everyday work, documenting and sharing their designs. Without this, they remain passive users of research instead of active contributors to knowledge about teaching and learning. Recently, interest has grown in using design patterns to address the challenge of designing technologies for learning. A design pattern is a semi-structured description of an expert solution to a recurring problem, including the context in which it applies. Its goal is to make knowledge explicit so it can be shared, discussed, and improved by the design community. This approach suits teaching because it allows teachers to participate directly in design. A pattern describes the problem, context, and solution, turning practical knowledge into something that can be shared and refined. Instead of traditional reports, teachers can express their insights as patterns, helping build a shared knowledge base. However, representing pedagogical designs is difficult. Text-based patterns are easy for teachers to understand but cannot be executed by computers. Machine-readable designs can be run in digital systems but may be harder to adapt. Many patterns are therefore semi-structured, using prompts and diagrams, but without a formal structure, they cannot fully support technological collaboration. What is needed is a structured, formalizable pattern that can clearly express pedagogical ideas and support sharing. This would help the teaching community build knowledge about learners, methods, and technology. The argument so far can be summarized. Teaching can be seen as a design science aimed at improving practice. Rapid technological change has pushed education into a reactive role. Education must define its principles and expectations of technology. Teachers themselves must help build the knowledge base. This work must be collaborative. Teachers need ways to describe and share their designs and results. This leads to the need for structured learning design patterns that support shared knowledge about teaching. The remaining challenge is deciding what form these patterns should take. Any design process begins with a requirements analysis. The next chapter does this by examining the core of formal education, the nature of academic learning, and the knowledge and skills it provides. Because this is contested, Chapter 2 explores different stakeholder perspectives. Chapter 3 then reviews research on students' ambitions, expectations, and prior experiences, asking whether this knowledge can help teachers better prepare for the learners they meet. To understand teaching, we must first understand learning. Chapter 4 reviews major learning theories across contexts and levels, showing how formal learning builds on natural developmental processes. Chapter 5 uses this to explore what teaching requires, noting that there is no simple link between teaching and learning. Because outcomes cannot be guaranteed, teaching must be treated as an iterative design process. This view suggests a more iterative and dialogic education system. Chapter 6 introduces broad design principles to guide teaching, especially in relation to digital technology, and argues that these should be expressed as learning design patterns. The following chapters examine major types of learning and effective teaching approaches, with and without technology. The final chapter brings these ideas together as design patterns and calls for a professional culture where teachers play a central role in meeting educational goals.